Hello friends, welcome to HP Vibrant Academy. In the last series of lecture, we have completed the discussion on the function and its types. So in this particular lecture, we will discuss about the symmetric group. So let's start our discussion. So what we have seen in the previous set of lecture is that the types of mapping. What are the types of mapping? Okay, so the first one is 1 to 1. Second one is many to 1. Third one is into. Fourth one is onto mapping. And the combination of these are, let us take 1 to 1 and onto. So this is 1 1 onto, 1 1 onto. Okay, and we have, let us take this as many 1 and onto, many 1 onto. Next we have 1 1 into, and we have many 1 into. Okay, so this 1 1 onto is also known as bijection. Okay, so this symmetric group Sn is a set of all the bijections from a set A to set A under operation star, and this star is nothing but composition of function. Okay, so this is basic structure of the symmetric group. So this Sn is a group. We are calling this as a group because it is satisfying the basic 4 properties for being a group. Okay, Sn is a group under operation composition of function. Okay, so the order, what is the order of this Sn? Is the number of elements in Sn is n factorial. Okay, so let us derive this. Order of Sn is n factorial. Okay, so Sn is a group of all bijections on n letters. Okay, so let us take a set. So we have the bijection is from 1 2 3. This is n letter. Let us name this as set A. So the bijection is from set A to set A, 1 2 3 up to n. Okay, so we have, and here the mapping is bijection, that is 1 1 1 1 onto. Okay, so let us take the set A here, and this is also set A. So the elements are 1 2 3 4 up to n, and here also 1 2 3 4 up to n. Okay, and this mapping F is bijection, that is 1 1 onto. Okay, so let us do the mapping. In case of 1 1, single element is getting mapped to a single element, and in case of onto, there does not exist any element in this codomain which is not having any pre-image on this set A. Okay, that is domain. Now let us do the mapping. So we have 1 can be mapped with any of these n elements. Okay, so 1 has n options. Okay, 1 can be mapped with 1 can be mapped with 2. Similarly, it can be mapped with any of the elements. So it has n options. So since 1 is already being mapped, so 2 is left with n minus 1 option. Similarly, 3 is left with n minus 2 option because 2 elements are already mapped. Similarly, n is left with 1 option. Okay, so the number of bijections will be number of bijections is equal to n into n minus 1 into n minus 2 up to 1. So this is nothing but n factorial. Okay, so the number of bijections is nothing but number of elements in group Sn. Okay, so we have the order of symmetric group Sn is equal to n factorial. Okay, now let us analyze this with a symmetric group, that is S3. So S3 is group of all bijections under 3 letters. Okay, 3 element set. Okay, so S3 is equal to set of all bijections, that is, this is F is bijection, that is 1 1 onto mapping. Set of all bijections from set 1 2 3 to a set 1 2 and 3 under operation star, and this star is composition of function. Okay, so we have the number of elements in S3 will be 3 factorial. Okay, so S3 will have the elements as, this is 6 elements. 3 factorial is nothing but 6 elements. Okay, so let us take the elements in set S3 as F1, F2, F3, F4, F5 and F6. Okay, now let us try to find. So these elements F1, F2, F3, F4, F5 and F6 will form group under operation star, that is composition of function. So S3 is a group of all these elements, that is all these bijections under operation star, and this star is composition of function. Let us try to find this F1, F2, F3, F4 and F5. Okay, so let us do the mapping. Okay, so order of S3 is nothing but 3 factorial, that is 6. So the number of elements are 6. So let us make this set. So this S3 is equal to, S3 is a group under operation star. So we have the elements as F1, F2, F3, F4, F5 and F6. Okay, so these elements form a group under operation star. Okay, now let us try to find this F1, F2, F3, F4 and F5. Okay, so let us do the mappings. This F1, F2, F3, F4, F5 are nothing but permutations. Okay, so we have, let us draw the sets. So we have this as 1 2 3, this is 1 2 3. Let us name this as F1. Okay, so we have already calculated that the number of mapping is nothing but number of mapping on a group Sn is nothing but n factorial. So this S3 will have 3 factorial number of mapping, that is 6 number of mapping. So this is F1 and this mapping is from set A to set A. Okay, set A is on n letter. Okay, so n letter, this is 3. So we have 3 number of elements 1 2 and 3. This is F2 1 2 and 3. This is 1 2 and 3. Okay, 1 2 3. This is 1 2 and 3. This is F4, this is F5, this is F6. Okay, so these are the elements that so group S3 contains all these bijections. Okay, let us find the bijections. So we have 6 number of bijections. So S3 will have 6 number of bijection because this is 3 factorial is equal to 6. Let us do the mapping. So we have this is 1 goes to 1, 2 goes to 2, 3 goes to 3. So this is one of the bijection. Now we have in F2, we have, let us name this as this is 1 goes to 1, 2 goes to 3, 3 goes to 2. Now let us take 2 goes to 2 first. So now we have 1 goes to 3, this is 3 goes to 1. Now take 3 goes to 3, this is 1 goes to 2, this is 2 goes to 1. Now let us do like this, 2 goes to 1 and 1 goes to 3, 3 goes to 2. In this case, let us take this as 3 goes to 1, 1 goes to 2 and 2 goes to 3. So these are all 6 number of mapping. Okay, so all these mapping are included in this group S3. Okay, so all these elements, that is F1, F2, F3, F4, F5, F6 form a group under operation composition of function. So this is nothing but a symmetric group under 3 letter. Okay, so we have the elements as F1, F2, F3, F4, F5 and F6. So these elements are nothing but the bijections. So this is, since it is a S3, so this will have 3 factorial number of bijections, that is 3 factorial is equal to 6. So these 6 number of bijections are there. So these 6 number of bijections will form a group under operation composition of function, as simple as that. So we represent all these permutations in 2 number of forms. Okay, so permutations are represented in either in array form or in the cycle notation. Okay, so we will discuss on this in next particular lecture, so don't worry about this. I will just represent these elements in a cycle form. Okay, so let us represent this. So we have the F1 as F1. Let us write down the elements here. This is F1, F2, F3, F4, F5 and F6. Okay, we are representing this in a cycle notation. Okay, so here 1 goes to 1, 1 goes to 1 closed. Now 2 goes to 2 and we have 3 goes to 3. Okay, so we will discuss on this in next particular lecture in detail. Okay, so don't worry how I am writing this. Okay, so don't worry on this, I will explain this in next particular lecture. So 1 goes to 1, 2 goes to 2, 3 goes to 3. In F2 we have 1 goes to 1, 2 goes to 3, 2 goes to 3, 2 goes to 3 and 3 goes to 2. So this is 3 goes to, this is closed. So this is nothing but identity element. This is equal to, so this is immaterial. Single element is cycle in terms of single element is immaterial. So this is 2, 3. F3 is equal to, in F3 we have 1 goes to 3, 1 goes to 3 and 3 goes to 1 closed, and we have 2 goes to 2. Okay, so this is nothing but 1, 3. Now we have F4. F4 is 1 goes to 2, 1 goes to 2 and 2 goes to 1. This is closed, and we have 3 goes to 3. So this is equal to 1, 2. Now we have F5. F5 has 1 goes to 3, 1 goes to 3 and 3 goes to 2 and 2 goes to 1. This is closed. And we have F6. F6 has 1 goes to 2 and 2 goes to 3 and 3 goes to 1. Okay, so the elements are, let us write down the elements. So we have the elements in elements in group S3 as, this is identity element, second one is 2, 3, third one is 1, 3, fourth one is 1, 2 and fifth one is 1, 3, 2 and we have 1, 2, 3. Okay, so these 6 elements form a group under operation star, that is composition of function. Okay, so S3 is a set of all these bijections that form a group under operation star, and this star is composition of function. Okay, and the number of elements in S3 is 3 factorial. This is equal to 6. So this is obviously 6 elements are there in this group S3. Okay, so we will discuss further in next particular lecture. Thank you.